Yeah. All right. Let me get that out of the way. Can y'all hear me? Everything's good?
Yes.
Okay. Thanks, Laura. I
You're
appreciate it.
welcome.
All right. Well, my name is Case, and that's Laura, and we're gonna walk you through two kinds of section of a really quick lecture that we prepped for this meeting. Some of that lecture we kind of reworked a little of it after some of the questions that we had yesterday to kind of focus a little bit more on some of the interests that the students had. What we're really going to focus on here is kind of a through line of machine learning and data set creation across multiple kinds of projects for different industries that me and Laura work on. And we're going to kind of show you how we cobbled together a career out of these particular pathways and skill sets. And hopefully, have a good laugh at a little bit of the kind of computational apophenia that comes with machine learning as a general discipline. So without further ado, let's do it. So we're Unit 3, we're Case and Laura, I just said that, so I'll move on. And an introduction. So I'm gonna start and then Laura will go. My name is Case. What you're looking at right here is a diagram that I tend to give to people when they ask me for a portfolio. What this diagram is showing you, besides being a fun animation that me and Laura think is funny, is the way in which I took two projects from my schooling at SCI-Arc, at the Southern California Institute of Architecture, and basically turned them into a number of aesthetic and research-based projects for clients ranging from like Daimler Chrysler and Nike to small musical artists and film, right? And I think this is kind of important because you'll hear, our students will hear us talk about this all the time, but I just kind of want to throw it out there and say that there's a lot of overlap in machine learning between the technical side and the aesthetic side. The aesthetics of, what we consider to be artificial intelligence is something that comes up all the time. What is it that we're actually looking at? How do we make it? What's the market for it? What's the use of it? And so what we tend to talk about is this idea of turning data into information. And this little diagram shows exactly how I did that. I'm not going to get into it, but I can tell you there are some of the highlights are like designing data sculptures for a Dubai exhibition, looking at the confluence of climate migration and global supply trucking routes for large equipment manufacturers who are kind of interested in that. So, and some forays into natural language processing and other places of machine learning that we're not going to talk about in any of these courses, but it's something that I'm interested in, and we'll probably touch on it if you're in Unit 3 a little bit. So now into Laura. That's my partner walking behind me. So just to go for
that. So basically, I saw Case's diagram, and I was like, I want that too. In general, I was thinking of this in terms of I would like to have a clear idea of the projects I've worked on, and maybe that'll help me figure out a clear pathway. This is what I'm interested in. It's very obvious if I diagram it. Here's what I want to do based on what I have done. I'm not sure it gave me that, but it's still fun to track the progress between starting to code in undergrad because I had to, not because I liked it, but then getting a job in energy modeling and realizing that in order to reformat the energy model with the software that's from the 70s, I had to learn how to code on the back end to make it do what I wanted. Then going through SCI-Arc and realizing that it can actually be a lot of fun because aesthetics were introduced, and realizing the freedom it gave me. And then applying that through working for Issued Rem Studio, through teaching at SCI-Arc, projects at Actual Objects and with Case, and then my own kind of tests and having fun with fashion and data sets, which I didn't really put any images in. I feel like my projects either inhabit an infrastructure climate engineering side or high fashion. There's very little in between, but yeah.
I do a lot of work in fashion too. I don't know I don't understand how that happens, but
yeah, whatever, it's fun.
I think the point of showing you this is that there's a lot of ways to build a life with these tool sets that are, can be interesting. And there's a lot of space right now open up in multiple industries on where you can, how you can use the kind of nuggets of things that we're going to try and introduce you to build out a portfolio, a practice, a pedagogy, whatever it is you're interested in, how you can spin it out. So me and Laura come from two totally different directions, but we've worked on quite a few projects together, and we're going to go through some of these projects and show you the machine learning components of these projects. This is a great diagram that Laura made, and it's animated like all of our fun stuff. But it's basically showing you the throughput of how we go about things. We get the idea, we create the narrative, we research it, we begin to build the data set, we test that data set, it goes horribly wrong, we rebuild the data set, we get the test out, we edit it, we run it, and sometimes sooner or later we actually get down to a product. It's a long journey. I'm sure
I
you'll
almost put an arrow like that would go starting over, like just starting the project over completely. But I was like, that's a little too pessimistic for this. But like that is a possibility.
I have a diagram for natural language processing for working with data sets involving sentences and language that is pretty much that. And we can talk about that when we get there. This is a Laura project. I'm gonna let Laura talk about it.
So this project I kind of threw in here because I find it funny, and it really highlights what we're trying to talk about with data sets, specifically bias within data sets. So this project was a project I worked on for Casey at Ishira Studio. And it was really, the purpose of this was to highlight bias in a data set that you're creating. So this was training an image classifier to tell me what was an architect or what was a not architect based solely on their image. So I had to gather, 400 images of architects and then 400 images of non-architects. It might have been like 1,000, I don't remember. And then I just trained it on that. So I gave it, here's what an architect looks like, here's what a not architect looks like, and then would test new images and see, what it gave me. And like, you're looking at this and you're like, this is obviously nonsense, right? Like Tom Main, who's arguably one of the most famous architects, at least, coming out of SCI-Arc and like on the West Coast, I don't know about here, is a 7.8% architect. Like that's hilarious. My mom is actually on the bottom, on like right next to David Rue. She's an artist and she's 94%.
It's the
and
glass.
it's like, yeah, she put those on because she was like, it'll make me look more like an architect, which like I respect. And like, I made this data set myself. Like I'm the one that chose the images. And because of that, like me Googling architect versus non-architect, recognizing where to pull those images from, like that bias is very tied into the answers of this, as well as the fact that the data set was very small. I put Sumin in here again. She's not here yet, but just because like to highlight, like she's 100% architect, whereas I am only 22% architect, apparently.
Which is kind of accurate.
I know, if you do the math based on how much time I've spent in school, like studying architecture versus engineering or whatever, I'm like, it's kind of fair. It just ends up being this kind of like this was like a quick turnaround for a project. And it's like kind of a fun idea that really highlights something super important within machine learning. Although I still get images sent to me all the time, like test what I am, but that environment isn't set up right now. So, maybe later.
And this is what we're talking about when we talk about computational apophenia, right? Like the recognition of pattern that is not there. So speaking of strange patterns, so we became interested in disinformation and how disinformation spread cross-platform, especially during the United States election last year. And so what me and Laura did was a combination of, down here in the corner, you can see our basic workflow diagram, and I won't bother you with how we built these data sets, although if you are interested, feel free to contact me and I'll talk your ear off about how to build natural language processing data sets. But what we did was we took we scraped all of Twitter for these particular users. We gathered their data, we put their data through a machine learning process and scored them on a score of 0 to 1. We then used those as the tent poles to begin to search. Oh, this is our verification model. You can see this diagonal line. I always point to the screen. Sorry. This diagonal line, this is our verification to see that the model, essentially we took we did a test. We took a data set that we knew was from them, and we tested it against our model to show that our model was at least somewhat accurate. It was, so we moved forward with the project. And what we started doing was taking this rhetoric that these political speakers in the United States were saying, and we started going down into different places in social media, and we started looking for what we call tactical communication, like how are words and messages being transmitted from elite public speakers down through social media, and how are those ideas moving across multiple platforms? And we started scoring them. And this is an example of like how we looked in one place and we found certain speakers were very prominent when you were talking about, let's say, the coronavirus at a large scale. And we started looking at how people were talking about coronavirus in California, and we started seeing shifts in who was more predominant. And I'm sure if you think about the power of words in the current global political discourse, you'll understand the power of having a tool like this to allow you to start looking at what people are saying. We also then started getting into computer vision and saying, well, okay, people post things. What about memes? How do we start to pool language from memes and start to score memes? So we used an open ORC computer vision to extract text from image, and then we ran that image back through the same model, and we started giving memes scores. This did not work as well as it should have, but it was really fun to try. And I'm really into memes, so there you go.
It was like nice to look through like hundreds of memes a day, honestly.
Thousands of memes.
Yeah.
We also started building user profiles of meme makers across the internet and started seeing like how different meme makers and the images they were showing started to correspond with elite public speakers, which is, a very interesting concept. I'm sure we could have a discussion about its validity, but that's neither here nor there. However, this all may not sound very interesting to an architect, but what I did with this project was then turn around and use the exact same workflow to start looking at how market values and public opinion around public spaces and different neighborhoods in the city of Los Angeles were being influenced by discourse online. So essentially, I turned it into a public policy project and a public policy analyst tool for advocates looking to change housing policy in Los Angeles. And I won't go into all the fun stuff that's involved with a really contentious space of public housing, but if you're a builder and you want to build and you're really into building multifamily housing, having a tool that allows you to start understanding what the people on the ground are talking about and what those attitudes are when you have to go through a public process of vetting a building and having public input and zoning and all those things that architects have to deal with when they get out into the field of practice. We started building a tool for that. One of the really interesting things, and this is like a diagram that I made for a presentation I gave to a foundation that was funding the project, but from very simply, we can start to pull from data set. We can build multiple data sets from another data set. So this is a really important idea, right? Like, how can we just continue to leverage our work to get more information from a single data source that we have? From this one little piece of text, we were able to extract, demographic and income information. Who are the people there? What do they make? What are their lifestyles? We can understand market motivations. We can start to look at how certain neighborhoods could be growing, or their value in those markets can be growing and shrinking. We can start looking at how people are trying to invest excess capital, which, if you're involved in urban planning in any space, that capital pushes policy. We also, then can catalog these users and track them. We can then also, we get dates and times. So we start to build a trend line. We start to take this information and put it into a temporal space. So now we can start to see how things are happening over time, how trends are moving. And this is the first step in machine learning towards producing, predictive analytics. We never got fully to predictive analytics. We're still working on this project, but I just wanted you to kind of see, like, the things that we're going to talk about in data set collection, at least in our unit, which we'll talk about in a little bit, are applicable. The same processes and workflows are applicable to a lot of different spaces and language and cultural products and images. They all kind of come together in these workflows. So without further ado, after public policy, let's go to like music videos, right? I put this in here because someone asked me in the open room, like, what is the entertainment industry? What is the entertainment industry interested in machine learning for? Like, what are you guys doing with it? And I was like, oh man, like they are so hungry for it, not just for as an aesthetic, but as a workflow diagram. So, oh, I'm not going to show this. That's insane. That's a
It
long
like
video.
accidentally plays. That was my bad.
But what we're going to talk, I'm going to talk about deep fakes, and then Laura's going to talk about style transfers and how we use those tools to create a very specific aesthetic for an artist. And I would hope that through that this little presentation you would be like, oh, I'm an architect, I'm an artist. How can I leverage aesthetics? So what we did in this, and I don't know if you can see my thing, is like we basically took this this musician and we took this actress and we put them together and we made, we deep faked them onto there so that this person is singing the process. Now that may not be super interested to you, but you might be interested in this, which is all the different machine learning tools it took to build that. One of the things that people, I think, tend to not think about, and I just want to say, is that machine learning, like deep fakes, are just a bunch of different machine learning algorithms stacked together in order. So one of the first things we have to do, and if you learn how to run deep fakes, what you also learn to do is run these things like DFDNet and different algorithms that are designed around a very specific type of technology for the 67 points on the human face and face tracking. If you ever use After Effects, if you ever do CCTV work, if you have anything to do with security cams, like, you're going to start to understand they're all the same algorithm. It's just how you deploy them. Down here below, we're using image segmentation as a masking tool. This technology isn't completely finished yet, but I think when it hits the market, it's going to be worth a lot of money to the entertainment industry. And also, just as a general aside, the aesthetics of this space is actually really interesting too, right? One of the things that we do a lot with once we have face tracking completed is we can start to build different kinds of masks with them. This is a really interesting part of deepfakes is not just grabbing that face information, but then being able to manipulate it through a series of different machine learning algorithms. And this is one in which we use training segmentation masks, which is actually a polygon-based mask. So it's a lot like you might see in Maya or 3ds Max if you're into polygon modeling. So there's a lot of crossover between those kinds of things. I won't bore you with how all this works unless you're interested, but I can assure you it's really fun. It's kind of problematic, and it's growing in industry for things like reshoots, actors who die in the middle of production. Like right now, if we shoot anybody, we grab a 5 to 10 minute video of just their face, of them reciting portions of the line, and we catalog that information so that later on, if we have to use their face, we can put it onto another actor. It's like standard operating procedure to start collecting that kind of information from actors. And I think, if you get more into VFX, we can talk about that later, but I just want to talk about machine learning stuff. Laura's gonna talk about how we use style transfer now.
Yeah, this slide actually, I'm laughing because the background is StyleGAN, but I'll start with that actually because it piggybacks off of. So one of the issues when Case was doing these deep fakes was some of the frames weren't working with the actress's face, and realizing that maybe it was just like she never moved her head enough to one direction, so that when the actual singer moved his head that direction, the deepfake was having a hard time kind of configuring that in a way that actually made sense or looked the way we wanted. And so then we're like, all right, well, maybe we could try and just generate more images of this actress so that to fill those gaps. And so it's like, all right, well, I use StyleGAN2 all the time. Let's run what you have through StyleGAN2 and maybe we'll just get more. So that's what the background of this is. It's like generating more images of that actress that did not exist before, in the hopes to kind of fill the gaps with like a different problem.
I mean, I think it's a really interesting, I don't know how much you guys talk about synthetic media as like a concept, but I mean, I think this is a really good example of synthetic media. Like, we were performing a machine learning operation. We didn't have enough data. We actually used the data we did have to generate new data, and essentially created a fake version of an actress in poses that she had never been in order to then turn around and put that back onto the actor. So synthetic media is another huge part of machine learning that we're really into.
And also, like, we have a problem, how are we going to solve it? So the style transfer part of this was, so the image at the top was a painting actually done by Claire at Actual Objects, which was like used as, was that a part of the concept art? It was like an idea for an overall feeling of it, or yeah, does that sound right?
Yeah.
And then the image on the lower left was like a still from the image that they from the video when they first shot it. So like kind of unedited raw image. And then we have like this concept painting, like what we want it to look like. It's like, great, well, let's just run it through style transfer. And style transfer is kind of like, I don't want to say like a dumb form of machine learning, because like that's rude, but it's not generating anything new. It's just taking a style of one thing and applying it to the form of another, which actually ended up working out very well for this, in the sense that, like, obviously on the bottom right, you can see how that is a perfect combination almost of the other two. And then this actually became a problem of like, great, okay, we have this idea of what we want to do, but now we have how many frames in order to make up an entire music video? Like, how are we going to get this done? How are we going to style transfer? All of these shots had, anywhere from 50 to 100 frames in them, and we only have so much time to get it done. So then that becomes a process of like, how many GPUs can we find, and how many like environments can I set up on someone's computer? Well, not enough while people are using their computers. So then they found someone who mines Ethereum, and he was gonna, basically loan us his rigs, like the 4 2080s, in order to do this. But then because this is running on TensorFlow and on Windows, like, we can't run GPUs in parallel and stack them into one. We would have to set up 4 environments on that computer. So that became a nightmare. So this basically just turned into, how many Google Colab accounts can we set up, in order to just like take this music video out, like shot by shot. I think, if you're in our unit, you'll have seen from our presentation yesterday that like a lot of this is like organization in order to get things done, and like how you organize the data sets in order to get it done is like applied the same way to, the music video as it was to any of our other projects, or what we're asking you to do. It's just also kind of funny.
Yeah, it's also kind of so we just finished doing an interview for this project, where it was an interview based on like how the technology of it works. Obviously we don't show them this, but like when you peel back the layers of what it really takes to do generative art, you see what a mess it is. Like, I mean, and this is pretty indicative of synthetic media in general these days. Like, it's still pretty wide open, and these workflows haven't been codified. They haven't been turned into into bespoke. You basically have to develop a bespoke workflow every time you want to try and do something. And I think that's a really important point to be made when you start thinking about how you want to apply machine learning to a project. So speaking of machine learning and data and its relevance, not necessarily to music videos, but to public planning and speculation. This is a project that me and Laura are currently doing. And it looks like a bunch of numbers because that's what it is. But this is a project we're doing for the largest largest trade organization in the United States. It's the American Society of Civil Engineers. These are the people who, you know, pretty much govern the behind the scenes, govern the you know, everything from airports to air traffic to roads to water to dams to sewer systems to electrical grids. I mean, they're pretty serious folk, and they have a pretty serious problem, which is that they are having a really hard time envisioning what the future of their practice is in the face of machine learning. Like what do they do when edge computing becomes so ubiquitous that what is the role of the engineer in this space? In order to solve this problem, they built a video game, you know, a huge sprawling video game of a megacity of about 50 million people. And then they brought me and Laura in to build the story of this megacity. Like, how do you, you know, and I think if you're in our unit, you'll be like, oh, I get it. I get where these guys are coming from. But like that became a game of data, right? Like a game of like data crunching, data projection. And I bring it up, we bring it up because I think that there's a really important understanding of like the relationship of these kinds of decisions that are made with how you build your data sets and what kind of data you're pulling and where you're getting it from, and how it can actually have a really concrete influence on people who are about to make some pretty serious decisions. I can't stress enough the different levels and of people out there that are clamoring to have someone kind of do an analytical project for them like this. And I mentioned Daimler Chrysler, and you know, like looking at like what is global trucking and climate migration, like how do those fit together, you know? And that became a project of data. Like how do we, where are those two going to cross? Like what kinds of data systems are going to cross it, and what types of machine learning systems are going to manage the interface between that data, right? And so this is where this project comes in. Laura, if you want to talk about, we like showing spreadsheets. I don't know if you noticed.
I know, so many spreadsheets, but whatever, it's my life. So like a big part of this project is like, okay, 50 million people, like I don't have a sense of scale for that. You know, that's so many people. These numbers are so big in terms of how much land, how much everything, that it was just like, we need to break this down into smaller chunks or bigger chunks, depending on, like, we need to take the data and process it in such a way that like my brain's like, okay, I get it. You know, in order to feed this amount of people annually, we need a space the size of Nevada to grow the food.
Yeah.
Or, you know, like we needed that kind of an understanding for scale, which was kind of the first problem I had, at least. And an example for this one was, we're looking at one of the districts. It's one of the denser districts in the city. And it was like, okay, well, you know, let's look at the percentage of the population. Let's say 10% to 30%, whatever, of the people live in this historic core. Based on how much area we've allocated to that, like, how big are these buildings going to have to be in order to fit that many people? Well, then you start looking at the average square meter, you know, required per person to live as a starting place. You kind of apply that to population and you start looking at, well, you know, we're looking at 23 stories at a minimum, and that's not including any mechanical floors, any structure. That's just people space. That's not including bathrooms or corridors or elevators or anything. Then you start to realize, like, oh, if that's a minimum for every building in order to fit this many people, like, you know, this kind of idea of projection for the future and like planning for that, like that directly affects architecture. If in the sense that we're designing, hopefully not a building for just the next 10 years, you know. I think it's related, but also like Excel helps, because then you can just run quick math in it and then change the percentage and see how it changes, you know. Yeah.
Well, I don't know. The next slide is just more of the same.
Yeah.
But I think what's important about this is that, like, when I started the lecture, I said, like, you know, how do you make sense of all this data? Like, how do you build? And that's why we started our lecture with a talk about world building and narrative. Is that, like, at some point, you have to communicate, machine learning is great if you want to like, StyleGAN or CycleGAN is great if you want to like scramble some images and like get some, find some apophenic images and start to kind of like, build a kind of aesthetic language around bizarre correlations of data. But you also need to start building a story around what's around allowing people to interact with that information or with that data. And one of the things that's really interesting about a project like this megacity is that it's the scale at which it exists is so enormous that actually the story becomes almost more important than the numbers, right? Like to tell you how many square kilometers of solar fields it would take to turn a city of 50 million people into 15% energy generated by solar panels wouldn't make any sense to you. But if I told you, this might also not make any sense, but like I told you, it's the size, you'd have to have a field the size of the state of New Jersey just to power 15% of the city. That's a story, right? Like that's a narrative. And so what we're trying to do in our project, in our workshop, and now we're in our workshop, is blend those two. Like build a project where you can not only use information to create interesting aesthetics and also a little bit of prediction, but also help you understand how to tell the story of what you're doing so that it becomes relevant to who hears it, as opposed to just being this, abstract computer generated abstraction. Not that there's anything wrong with computer generated abstractions. That's just not what our workshop is about. Well, okay, it is. And then we make a story about how we got there. Here's this great thing again. So I don't know how much of this we want to go through. I'll leave it to Laura to kind of, we gave this speech when y'all met us. Laura can talk a little bit about like how these images right here are actually related to the process we were talking about. Do you think would you like to do that for a little bit, Laura? Or?
Yeah. Well, I mean, for this image, I guess, and I think tomorrow and well, starting today and moving forward for our unit, but also just in thinking of how do you start this? So a lot of it is like, what is the city going to be like? Like, what are our design constraints in terms of how the city has changed when we're doing this? So I started by, let's see what CycleGAN looks like. Let's train it against Miami, Florida, or I did one against New Orleans, or let's take like a city that's overlaid with the grid so it's more pixelated and train that into something new and just kind of like see what I would get out of it. And the point being, yeah, this is like the images I use to train the site of Seoul into some Miami, New Orleans mutated combination. Why those two? Because I was like, Miami, there's a lot of water, islands broken out. In my mind, climate change, sea level rise, that's going to be a big problem that any city with water or a river is going to have to deal with. Same with New Orleans. Like New Orleans is notorious for having to deal with anything related to hurricanes, flooding. Like that's a huge issue. So in my mind, like that's all narrative driven. Obviously, Seoul is never going to turn out to be a combination of Miami and New Orleans, right? But so yeah, these are just some more images of like data set creation. So like, what is the data set for you and how important is that? Like that can be memes. Like this is related to the disinformation project. Again, like super fun to be looking at memes all day, but that ended up becoming our data set. Is it language that you're going to use for an image, for generating image captions or for natural language processing? Is it going to be, like running it on building plans, either existing and like, do we want more building plans of the same type? So then you have to create a data set that's like, all my building plans have to be by the same architect. Like I'm only going to recreate plans that are like Nice, but like if today and then by AI, or it's like you just pick your favorites and you're like, well, this is the architecture I like, so let's just generate something that's similar to that. I did that actually, and everything came out super brutalist. And I was like, I guess it makes sense. And then, again, playing with fashion, like this is a data set that's like, I scraped as many Nikes as I could together, ran it through StyleGAN too, and like, let's see what happens. And in general, they look a lot like Nikes. Or a project that I'm working on right now is collecting faces of K-pop singers, like as one does. Like I've spent weeks just gathering images of faces of people in K-pop in order to, like, that project will come out next month. You'll see it then. But yeah, I guess it's like data set creation is going to be different project to project, but the actual idea of putting it together, the methodology of these processes for these projects is basically the same.
Yeah, and that pretty much concludes our lecture. And I think it's a good place for us to kind of wrap up on, to say that, like, you know, data set collection is pretty much the root of all of it, you know, like at the end of the day. And then, you know, not only the processes and the workflow, but the sort of philosophical implications of what it means to build systems like this at this level. Might not be there might not be a lot of not a lot of risk, you know, in what you're doing in a workshop. But as you go out into the world and begin to start collecting data sets and training these kinds of things and start deploying them into all kinds of who knows what spaces, you know, it carries with it a kind of conceptual, ethical, and sort of moral dilemma that's baked into the process. And we kind of don't want to shy away from that. You know, we kind of want to run head on to that, and that's sort of where we're at, you know, and that's us. That's Unit 3 in a nutshell. I think if anybody has questions, we'd be happy to answer them. And if not, thanks for taking the time to listen to us.
Thank you so much. Yeah. Very inspiring, really inspiring. And sorry I joined late today. But yeah, do we have any question? I'm sure it was really, really overwhelming. Yeah. Any question from the audience?
Did you see that you're 100% architect, Sumin?
Yeah.
I showed the architect, non-architect.
Yeah.
So yeah, I had to throw you up on that.
That's so fake. I'm not 100% architect.
Like, that was like the funniest part, was people were like, that's not true. I'm not 100% architect. Like, run it again in a photo. And I was like, that's the point of this design.
Yeah, yeah.
Well, if nobody has any questions, you know, we're around if it should occur to you that you want to hit us up. I'm sure there's plenty of pathways for you to contact us via the program, and hope you enjoy the next one.
Yeah, thank you so much. Yeah, if we don't have any more questions, we can come back at hour. So it's 7:42 now, right? So we'll come back at 8.
9:42 in Korean time.
Oh, sorry,
so
sorry.
we're gonna start at 10 o'clock again.
Oh, 10. What time is it in Korea right now?
It's 9:42 in the morning.
9:42.
Yeah.
Okay, so 10. We'll start the Unit 4 at 10. Okay.
Okay, see you later.
Yeah, thank you very much.
Thank you,
Thank you.
lowercase.